If it's true in both situations, it is in fact a solution to the system of equations. Let's try and see what happens. In the case of the first equation, we're going to substitute 2 for x, the 6 for y, and it should equal 8. In fact, without any additional work, 2 plus 6 does indeed equal 8. That's a true statement. Let's take a look at the second equation. 3, and then substituting in 2 for x, and then subtracting 6 should equal 0. 3 times 2 is in fact 6, and 6 minus 6 equals 0. So since it's true, this point makes true statements out of both equations, it is a solution to this system of equations. Now, on to what we really mean to do for today. By graphing the two lines and graphing this following system of equations, we can figure out what the solution is, if there is one. So, let's take a look at this set. I'm going to move this up a little bit and pull down some graph paper. Turn it over. Okay, so in this case, I have a graph and I have the equation x plus y equals 5. In the second equation, y equals 2x minus 4. The first equation is in standard form. We can graph this equation quite easily by simply using the cover-up method or putting zeros in and using the x and y intercepts. In order to do that, I want to find the point when x is 0, what my y value is, and when y is 0, what my x value is. Okay, so I'm putting 0 in for x, which in effect allows me to cover up my x because it's gone, and I end up with y equaling 5 when x is 0. I put my 0 in for x, or for y, I cover up my y, and I end up with x equaling 5 when y equals 0. This is fairly easy to graph. I have 2 points, 0, 5, 0, 5, 1, 2, 3, 4, 5, and 5, 0. 1, 2, 3, 4, 5, and 0. If I try to draw my line carefully, it looks about like that. Okay, graphing the second equation it's in slope-intercept form, which makes it easy to graph right away. I go to -4 on my y-axis, 2, 3, 4, and then I go up 2 and over 1 for each step thereafter from this point. Up 2, over 1, up 2, over 1, 2, over 1, up 2, over 1. And I think I've already found my solution by graphing this carefully. Notice that the point 3, 2 is in fact the point that both lines share. That is the point that makes both of these equations true at the same time. That is the solution. And that is what we're looking to do.